Hello ladies and gentlemen, welcome back. This tutorial video is for students who are in Algebra 1 Goal 3 as I continue to make these videos in reverse order for some reason. Currently we are working on Family 4, which is taking some basic skills that we've learned in the prior family, the one I haven't made yet, and actually start using it all at once in one topic. So we're going to start with power and products. The thing to keep in mind is, and it's handy to sort of write off in a corner somewhere, power lag times a power is addition, a power to a power is multiplication. Those are the two things that we want to keep in mind. Power times a power, addition, power to a power, multiplication. And as a result, you kind of have to do this order of operation style. You have to take care of your multiplication first. So here is my multiplication, aka my exponent. And suddenly it makes sense when you're looking at PEMDAS, exponents come so high on the priority list. We're going to take that 2. If my computer stops lagging, and we're going to distribute it to everything inside the parentheses. So 3 squared is 9, y squared is just y squared, z squared is just, z squared, times 3x squared y cubed z to the 4th. Now, in an earlier topic for students who are first looking at this and having a little bit of trouble understanding how to keep track of all of these numbers and letters, what I tend to point out is get your likes together. So you have 9 times 3, you have y and y, so y squared times y cubed, you have z and z, which is z squared and z to the 4th, and then we have an x squared at the end. Because you've taken the time to rewrite it and reorganize it, it looks a lot easier and then makes it easier to, in fact, simplify. So 9 times 3 is 27. And then we have x squared, because we didn't touch it at all. We have y to the 2 plus 3, which is y to the 5th. And we have z to the 2 plus 4, which is z to the 6. And that, therefore, becomes your answer. Similar idea here. We're going to take our powers and distribute them to everything inside. Distribute them to everything inside. So negative 2 cubed is negative 2, 4, negative 8. So negative 8. Power to a power is multiplication. That's why we're doing this first. So x to the 4 times 3, which is 12. Y to the 1 times 3, which is 3, z to the 1 times 3, which is 3. All of that times negative 2 cubed, which we just figured out is negative 8. And then it's going to be x to the 2 times 3, which is 6, z to the 2 times 3, which is 6. Aha! Now, some students can do the multiplication necessary from here, but just in case if you struggle a little bit, we're going to rewrite this. So this is negative 8 times negative 8. Then we have x to the 12 times x to the 6. Then we have y cubed just by itself. And then we have z to the 3rd times z to the 6. Negative 8 times 8 is 64. X to the 12 plus 6 is 18. Y to the 3rd, and then z to the 3 plus 6, which is 9. There's our answer. And suddenly you realize the math itself, much like with all of the other topics in Chapter 3, is not all that difficult. All you're doing is just keeping track of what you're doing first. So if you're really good, then you know this is going to be negative x to the 9th, y to the 12th, z to the 3rd times 3yz to the 3rd. So our final answer is going to be negative 3x to the 9th, y to the 13th. I say that because this blank, which means it has an invisible 1, and then z to the 6th. Next one, 2 cubed is 8 times 3 is 24, and you're starting to see Ms. Dubois do this live in her head. X cubed is 9, and then there's no mate over here. Y squared cubed is to the 6 plus 8, which is y plus 2, which is 8. You see, my brain was working too fast. My mouth couldn't keep up. Z to the 3 times 3, which is 9, plus 2 is Z to the 11. Now, when Ms. Dubois is doing math in her head, that's how she does it. I was able to say it out loud for you guys to follow. But obviously, especially for beginners, you want to do this one step at a time until you're comfortable with it first. Next up, if that's what power to a power is, what is power divided by a power? So if power times power equals addition, computer, power to a power is multiplication, then a power over a power is subtraction. Now, why is that? That's the question for the ages. Well, not quite for the ages, but still, subtraction. Let's do this out the long way so that I can show you how this works and why it's kind of cool. When we look, computer, what are you doing? When you look at y to the 4th, that's in expanded form, meaning I write out all of the multiplication. That's 1, 2, 3, 4 y's. That is 2 z's for z squared. Next, what do we have? We have 1, 2, 3 y's, and then we have 1, 2, 3, 4, 5, 6 z's. That's what this means, correct? So, an old adage from middle school, any number divided by itself is 1. So, y over y cancels to 1, cancels to 1, cancels to 1. Same for the z's, cancels to 1, cancels to 1. Well, gee, what are you left with? Y over, how many z's are left? 1, 2, 3, 4. Y over z to the 4th. And here's where it starts getting cool. What's 4 minus 3? 1. What's 2 minus 6? Negative 4. And negative exponents means it flips in the fraction base, which is what's really cool. I'll do one more in expanded form, and then I'll do the outright shortcut. So this is 1, 2, 3 w's. Oops. Then we have 1, 2, 3, 4, 5 v's. That's what w cubed v to the 5th means. Then we have 4, 1, 2, 3, v, v. That's a w, Mr. Ball. Computer, keep up. So w, w, w all cancels. V and v cancels. What are we left with? V cubed over 4. And let's look over here to make sense. See if that makes sense. 3 minus 3 is 0. It completely disappears. 5 minus 2 becomes a 3. So you're left with the v cubed, and you have the 4 underneath because that's literally all that's left. Now we can show you doing it by outright subtraction. So this is y to the 6 minus 1, and that's going to be x to the 7 minus 4. What are we left with? Y to the 5th, x to the 3rd, and that's our solution. Next one, 7 minus 5, that is z squared. 1 minus 4 is negative 3. Since it's a negative, we drop down and flip where it is on the fraction. And that's what division is going to look like. So there's one last little trick for this particular family before we can consider it done, and that's knowing what 0 powers do. And here's the short version. Anything to the 0 power is just 1. So if we look over here, 4/5 to the 0 power, that is 3 parentheses 1. And then you simplify that to just be 3. 4 to the 0 power, that's just 1. 9 to the 0 power, that's 1. And then we slap a negative in front. 1/7 to the 0 power, that's 1 times 2. So our answer is going to be 2. And you start to realize, oh, wow, miss, this one's actually low-key kind of easy. And this topic in particular, having things with exponents of 0, that pops up in quite a couple other topics to keep in mind, especially when you're graphing your exponential growth and decay. That's a DSA question. Handy little thing to keep in mind. Negative 5 to the 0 power, 1. Negative 1/5 to the 0 power, 1 times 2, which is just 2. Let's see here. Anything to the 0 power, that's 1 times negative 2, so our answer is negative 2. And then 3/2 to the 0 power is 1, and then we slap a negative in front, and then there is our answer. So that is everything for Algebra 2 Goal 3 Family 4. 3 very fast topics to get you used to some of the basic computations. Next family will be Family 3, where I go into more depth about how some of these power rules came to be. As always, stay happy, stay healthy, stay safe.